All right, we're literally going to go to the top leak code for Amazon System Design. All right, the question is design a real-time ranking system for a gaming company. Count of entities can be multi-millions. So, all right, first let's figure out the general requirements, inputs and outputs. What is the limitations of this system? Is it a website? Does it need to make REST calls? Is it a service that we're going to make API calls to? So let's start with that. Like, what are the inputs? Let's say since I'm making this up myself, let's just talk about some of the ways the inputs could be. What about the game? Does the score matter? Is it like, football where one team wins 60-28, or is it more like chess where it's just one side concedes? So that is kind of the input, and what is the expected output? What is how do we expect to query this? Who wants to use it? Is it a matter of just getting a leaderboard purely? So it's just the numbers, ordered numbers of the best and top players, or is it a matter of like needing to compare one person against another and knowing probabilities? Since the question says a ranking system, I'm just kind of reading back into the question a little bit and trying to narrow down from there. I'm going to assume I'm going to simplify and say that it's just a win or loss mechanism. Another thought that just occurred to me is like, how many players? I kind of assume there were only 2 players in this game, but that's not necessarily true. Video games can have like a 10v10 or 100 versus 1 versus 100. But for the sake of things, let's simplify to a 2-player game, and there's only one clear winner. And I think we can expand upon that if there's ways we want to increase difficulty. So just purely based off of this, I know I know of ranking systems, right? There's chess rankings, there's ELO, but I certainly don't know them well enough to speak about them, especially on the spot. So I'm going to try to target a more simpler winning system that I can actually, think up on the spot, and that might work for the requirements. So given the constraints that I've kind of put onto myself, 2 players and just win or loss, I think a really natural statistic to use is the ratios of wins to losses for each user. So there's a few parts to this, of course. There is the straight number. Like, if you win one game and you're undefeated and you have 100% win rate, are you really better than a person who has played 1,000 games and won 999 of them? So like, this depends. Like, I'm sure we've probably all seen review websites like reviewing products where you say, oh, I want the best, the highest ranked products, but you actually only get you may get there was only a single review, but it's 5 stars. So, and sometimes that's okay. That's not always a bad thing. That is literally what the customer asked, even though that may not be like you're designing what the PMs are, what the product manager is asking for, but maybe that, like, you can kind of intuitively know maybe this isn't the best, maybe this is what they said, but maybe not, it's not what they want. um, so I'm just calling that out to be aware of it right now, um, because I think just that sort of waiting um, can vastly increase the scope, at least of what I'm working with right now. So let's continue talking about, just let's say it's okay that if someone is undefeated, even if it's only one game, it's okay for them to be much higher ranked than someone than someone who's consistently won but has lost once. Um, so in this case, let's after every game, we should probably talk a little bit about the database. And I mean, we're probably gonna update this database as it goes, but we know one of the columns in this database is definitely going to be um, player ID, let's call it. And player ID will of course be the primary key, the unique key that that has like is unique to each player. And what's important here? Do we need to store a record of every single game they've played? Like player 1 played against player 10 and lost. Do we need every single entry there? No, it doesn't sound like we do. At least with the constraints of the, like in a real gaming company, yes, you probably do want a record of every single match. But at least in terms of the requirements, and maybe like you're just building a small part of the system and they'll store the full result somewhere else. In terms of our system, we only need to know about the ratio, basically, right? And the only way to derive the ratio is to know the total number of wins and total number of losses each person has had. So let's create an API and let's call it submit score, or like submit. Let's better than that. Let's say submit winner. No, that's not good either, because it's not just the winner. We want it. We're not just saying that a player has won, but we also want to calculate. We also want to update that another player has lost. So let's say submit game results is the name of the API. With that said, it would need three. Okay, well, it really needs two, possibly three or four inputs. The two would of course be the player. I'm going to continue on my example and say player 1 and player 10. And we could be a little. And purely based on the order of parameters coming in, I'm kind of thinking of this, by the way, like a Java call, not a like a JSON payload. So I'm thinking that order of parameters can matter here. And we can also talk about if it was like a JSON or something else, but basically I'm going to say that the first parameter, the first player that you pass in, is object player ID, so string, and it should be it is the winner. So we just assume whoever comes in as the first param. In fact, let's name it. Let's just name it string winner. Winner player ID. Let's be more specific. Right? And then the second parameter would be a string of player loser ID. And I mean, this seems like a pretty simple, like whatever your backend is, DynamoDB, SQL. In this case, we don't really have a relational a reason to be relational. So I'm just gonna say it's DynamoDB. So I mean, it doesn't really matter what you choose, but you query for winner first. Um, what else? What else are you getting? What are you getting back from this query? You're getting back the wins and losses, is what you need. Is Well, yeah, I mean, like you get back the entire row, right? Which would be like the player ID, the number of wins and number of losses. But all you need to update is you need to add one to the winning count, and submit that back, save it back to the database. Similarly, you would just do that for the player who lost. In this case, both players are updated after a game has ended. And at least for now, I'd say that like this API let's call it finished for now. So this is how we just get some numbers, get some values into our general system, right? And again, I'm not done yet because I don't know if this is all the columns we need. It kind of depends on how this data will be used. How will it be queried? Is it expected to show, like, you're querying for a specific player's profile and you want to just get a ratio back? If so, then what we have so far is enough. You could, or even if you were like putting two players together, like seeing which player has a higher rank, you could always it's trivial, O of 1 time operation to query each individual record, divide out their wins by their total number of games, and compare what is their win ratio of these two users and what's the higher one. That said, if we want an actual ranking board, top 10 players, top 100 players, maybe you want it for every single player, out top 458,000 players. How do we keep that up to date? So actually, I'm going to table that. I think this is a natural progression of the question. So I will get to it. But what I was thinking about addressing first was, the usage. What is like the performance and expected usage? Because, I mean, this is kind of a silly like example, but if there's only 10 players, we can always query all of them. If this is a massive multiplayer online game, which is what we're going to actually assume, then we need to do a bunch of optimizations in order to always be able to quickly tell who are the top 10 players, right? So on top, so let's bring it back to what else we need to store. So right now we have the player ID, the wins and the losses, right? And what would be useful in us like instantly knowing who's at the top, who's at the top of top 10, like top X, is actually storing the ratio at the same time as well. Because if you store the ratio, then you can just do I'm kind of assuming MySQL now. You can sort by descending and just pull the top X records off of all players. So I see an opportunity to cache as well, but I'm also gonna kind of table this on the side, and when we'll come back to this. The downside of this is that every time you query, we'll come back to it very soon. But like kind of the downside of this as it is right now is that every single time you let's say it's a web page that shows the results, the top 10 users, the SQL database will sort by descending, right? There's probably, I mean, I'm only really familiar with DynamoDB and MySQL, to be honest, but um, of course, there's probably a database that kind of follows a data structure that's more like a linked list, um, where we could always keep this list up to date, right? Once a player's game has ended. Um, this is kind of interesting because we'll have to find out where in the linked list. Let's say it's like just a string from player number one to player 500,000. A linked list of all the users. We kind of need to know, like, did he jump multiple steps? Did he jump multiple ranks? Um, but like the advantage of storing it like this is that you would always, without caching, without sorting, always have the top 10 at all times, right? And be it O of 1 operation, O of 10 to grab the top 10. I think that's really interesting, but I'm gonna stick to what I know, in terms of our limited time. Um, and let's use the MySQL descending by 10, but we will cache the results on a frequently hit page, right? Like the home page of a game, and that always wants to show the top 10 players. In this case, we'll have a separate table. We can store the top, I just keep using the 10 example, but let's say it's the top 100 in this table. And each time, like, we'll determine a frequency such that whenever, like, a frequency of time, so let's say it's every once a day. Once a day, we will do the sorting of the entire table, entire player ranking database, which I should have named, actually. I should have named the table to give more context and explanation to this. But we'll do the sorting, which is going to be like, even in the multi-millions. Like, SQL should have no issue sorting by descending and only grabbing like 10, as long as it's like one time a day. And grabbing the first 100 and updating that other table with it. That is probably that's the simplest way, right? Caching and doing it on a timed interval. How are we doing on time? We're at 18 minutes, so we still have plenty of time. So let's talk about how we can improve that. How can we give real time updates? Because this smaller cached set could very well be updated in real time, I think. So let's take it a step further and say that now that we've, like, in the cached set, we have a reduced number of entities, right? Of entries. We can do things that we couldn't do before, such as always keep it updated by sorted order, right? So what I'm thinking is, when we call what do we call, like, submit game results API, we can, after updating the loser and winners ratios, like the numbers, the counts, we can take I think we need to do it for let me think about this a bit, but I think we'll take a look at both ratios. Like, potentially the loser could have been kicked out of the top 100, let's say, and the win or the winner could have entered the top 100. So both of these are possible like, simultaneously. Um, so for let's look at the winner first. So first we see if actually let's it doesn't matter which one we do first. So the winner, we need to insert them into this table, right? Like so once we find out the new ratio, let's say it's high enough to enter the top 100. It's, just to give an example, 80% win rate ratio. In this case, how we need to check if they should be entered into this cached table is compared to the lowest rank. That's the quickest check here. So grab the lowest ratio. I guess sort by descent. Sorry, sort by ascending, so that you'll have the lowest value first. I might have screwed it up earlier. I apologize. But we sort by ascending so that we have the lowest number as our top row. We just grab the top row. We just want one result, and we compare against that. Are we lower or higher than it? If we're higher, then we know this user belongs somewhere in this list, and we can insert them. And then sort this list again and maintain it that way. Save it as a stored list that way. Now we have 101 users, right? The second thing I want, I know we only want 100, but I think that's going to be the last operation here. Then I just want to know if the player 2 has dropped out of the rank. So this one's pretty easy because we can just say was player 2's player ID in this contained in that list of 100. If no, we're done here, and we can just drop the lowest record, the lowest record that the winner kind of kicked the bottom user out of. If the loser was in fact a part of the list, actually, let me think about this a little bit, because they would only be dropped if they were the lowest. If they were the lowest ranking, they were like in 100th place, right? And then we already have the logic that would have taken care of that. They would have been 101 now, and they would have been dropped. And if they were somewhere within the list, they were like number 95, and now they're number 96, but it's still not that, it's not bad. It's not bad enough to be dropped. We're also taken care of because we'll just drop 101. Yeah, and we're going to continue sorting. So even if he's changed ranks, it'll stay there. We're going to sort after updating the winners. So I don't think we actually need to update the losers specifically. This is also something we didn't necessarily need a database for. It's something we could keep in memory, as long as the system is somewhat stable. We would not need to spin up a new database for this. Just like when a server goes up, it builds this list of 100 itself, and we can maintain this list as a linked list in memory. that's probably very feasible as well, and may save some money, especially depending on like how many servers we need, or how many database, like how big does this database, how big of a load does this database need to scale to. Yeah, that's kind of where I'm at right now. We're at 25 minutes, so that seems like a reasonable place. But let's say they just hit me with a curveball, and it's let's see, what's the question? I mean, I kind of talked about optimization already. Truthfully, I have no idea. Let's see this leak code list. Does anyone say anything? I'm I'm not really seeing much comments. That's like a good way to expand this question. So I'm gonna leave it at that. I mean, if they have questions for me, of course, I'm happy to answer them.